Hi folks, Mr. Tyke here. We're going to do some examples of rational functions, and I'm going to show you what I expect you to be able to do on the test. And we're actually just going through some functions that we used in class. So to start, let's have, let's see, the function. I think I started you guys off with this one. Okay. All right, so I got three linear factors on the bottom and one on the top. So let's see, what kind of things do I want to know here? I want to know y-intercept, x-intercept, horizontal asymptote, vertical asymptote, holes, and three more points. So, and then I want it all on the graph, and then I want you to sketch the curve. So let's do all of that. So the y-intercept is just substituting 0, right? So if I substitute 0 here, I'll do the work down here. Let's see, f of 0 is, well, I can see what I would have. If 0 goes in there, I just have these other parts, 7, 2, negative 5, 7, negative 5, that is. So on the denominator, looks like I'll have negative 70, so I have 7 over negative 70, and I could even just divide this, just like I can essentially divide this, but we'll say more about that in a second. So I have 1 here over negative 10. So my y-intercept is x is 0, of course, and negative 0.1 is my y-coordinate. So I can put that on the graph right away. So that's right here. And that's my first feature there. So x-intercept, okay, now what numbers make the numerator 0 but not the denominator? And the answer to that is no numbers do that, because the only linear factor on the top is x plus 7. The only number that makes the top 0 is negative 7, but negative 7 also makes the bottom 0. And I would have 0 over 0, which is indeterminate. So there is no way to make this function equal to 0, so I don't have any x-intercepts. All right, so the only way I can have one of these is if I can make this top 0 without making the bottom 0. Okay. Horizontal asymptote, we said that had to do with the degrees. So the top is degree 1, and the bottom is degree 3. And I see that because if I multiply these factors together, I would have x to the 3rd power. And here I just have x to the power of 1. So since it's a greater degree on the bottom, this function will go to 0. Like the limit at infinity will be 0. In other words, if I plug in 1,000,000 here, remember when we plugged in big numbers? If I plug in 1,000,000, I'd have 1,000,007 over, well, approximately 1,000,000 times 1,000,000 times 1,000,000. And so clearly that would be a value very close to 0, 0.000 something. In other words, the bottom of the fraction getting really big a lot faster than the top of the fraction means that this thing will shrink down to 0. So that means that's the limit at infinity, and so when I graph this, it's gonna go to that. In other words, there's a horizontal line here at y equals 0, which, yes, that's the x-axis. So it's hard to draw the x-axis on top of the x-axis, but just do your best on the test. Make it like that. And that means that the curve is going to do something like this. It's going to, as x increases, it's going to swoop down, or it's going to do something like this, or, you'll see. But basically, it's going to approach that x-axis asymptotically. Vertical asymptote. Well, in order for this to occur, I need to have some number that leads to division by 0. So I can see that if x is negative 2, I'm dividing by 0. If x is positive 5, I'm going to be dividing by 0. If x is negative 7, I'm going to be dividing by 0. The vertical asymptotes will be at x equals negative 2 and x equals positive 5. There will not, the negative 7 is not a vertical asymptote because essentially, because I have the same factor, and people say, can I cross these out? Yes, you can. And once you do, the function will imitate. So I can say this is not really the function we're graphing, but it's a lot like this, because if I divide these out, this is what I get. So that being true, I can see here the only vertical asymptotes I would have would be this and this. Now the fact that I can divide them out means the function ignores the fact that -7 is going to be a discontinuity until we actually get to -7, and then we'll have a hole. So the hole occurs at the value that makes a 0 factor in the numerator and the denominator and leads to 0 divided by 0. That's where I have a hole. Other discontinuities, -2 and 5, those are places where I'd find vertical asymptotes. Okay, so I have everything I need other than the 3 points. And for the 3 points, I just want to substitute. Before I figure out the 3 points, let's do the rest of this. So I have the y-intercept, no x-intercepts, got the horizontal asymptote, vertical asymptotes here and here. And finally, I want to know the shape of this thing so I can actually sketch it. And in order to do that, I'm going to do two things. One is I'm going to use the graphing calculator to just confirm what the shape is. But first, I'm going to get an idea of the shape by plotting some more points. And I want you to do at least 3 points. So I want you to use an x value out here, an x value in the middle, and an x value out here. Because of these lines, this is a break in the action, and so is this. That means there's going to be 3 separate areas here, or regions here, we'll say. And in each region, the function's going to have a branch. So there are going to be 3 branches. And it's all the same function, but they will be disconnected branches of the same function. So I want at least 1 point for each branch so I can do that. So I'm going to say, how about -4 here is a good place to go to get a point. And then maybe, let's do 3. And then 7. Let's use those x values. So I'm going to say -4 goes in, and I'll substitute that. I could substitute it into here, but I might as well sub it into here because that's going to give me the same result because these divide out. So let's say -4 plus 2 is, let's say, okay, so I have -2, I've got -9, that's 18. So I have 1 divided by 18. I have, what was I going to do? 3, so that's 5 and -2. So 1 over -10, so, oh, look at that. Same value. And then for 7, I have 9 times 2. Oh, so I'm back to positive. Okay, so none of that was by design, but I have some repeating function values there. Okay, so this is going to be just, and I mean, this is tricky because all of these values I'm plotting are right, it's, you know, it's not very dramatic, these points, because they're all so close to the x-axis, but maybe that's just the shape, maybe that's just the nature of this function. The important thing is this is positive, this is negative, and this is positive again. Okay. And, you know, the fact that these are exactly across from each other, that suggests to me that we're going to have either a middle section that either does this or does this. It's probably not going to do this. In fact, I could prove that it's impossible for it to do that or that, and it would have to, you know, essentially be entirely convex or concave. And this one right here, I can certainly predict now that it's going to do this, as opposed to doing this or whatever. And this will do this. So I guess you can't be, even that you can't be 100% sure of until you try it out. Okay, another thing I'm seeing, make sure, I'm going to show you how I put this into the calculator because people are, let me show you the wrong way to do it. Here's what I see people doing in class frequently. Whoops. Okay, now if you, hold on, insert an x. Okay. Now, if you do it this way, and this is your function, let me just show this side by side, because this is a real problem, guys. See this right here and this right here? That's not the same, okay? Now, what's the difference? Well, right here, you've got this fraction bar, right? Now, that fraction bar needs to be that's division, right? That fraction bar. That division is the last operation that's supposed to be happening here, right? That's how you read this expression. You're like, okay, all these operations here happen, all these operations here happen, and then that division happens last. Now look at the way we entered this. What's the calculator going to do? Well, it'll do the addition, 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 and addition, right? Or the subtraction and the addition, because those are in parentheses. But then what's it going to do? It's going to divide and then multiply, and that's not what you want. You want these. You basically, what I'm getting at is you gotta take care of the whole. Put parentheses around the entire denominator. That way, everything in the denominator gets taken care of before you divide, because that's what's happening in the expression. The calculator doesn't know any better. Whoops. Really? Okay. Maybe this thing's low on battery. But anyway, yeah, the calculator knows order of operations, but it doesn't know what the implications are in how you wrote your expression. So that's what you have to do. Anyway, here we are with the graph, and that's pretty extreme. It's not even. Let me fix the window here. Maybe if we do something like make the y's a little more gradual. Okay, so now, well, that's a little better. Yes. This is a low resolution screen, and it cannot handle the steepness here. But you see what's happening now. So, okay. So now I can finally sketch my curve. And as long as it goes through the points that I plotted and it agrees with all the elements, it doesn't have to be perfectly accurate beyond agreeing with, what you determined here, like the x-intercept, the y-intercept. It's got to go through those points. It's got to, obey the asymptotes. But other than that, if this is not perfect here, that's okay. All right? So that was the first example. Now I talked a long time, so I'm going to do, I think, a couple more examples, but I'm going to do a lot faster. Okay? So, let's see. Right. Okay, so let's do a couple more. And these are also what we did in the team drawing activity. So, all right, so on the side here, f of x equals x plus 5 over x plus 6. Okay. Y-intercept. Plug in 0, you get 5, 6. X-intercept. What makes the top 0 but not the bottom? -5 will do it. Horizontal asymptotes. All right, one asymptote actually. What are the degrees of the top and bottom? That's degree 1, degree 1. Same degree. Then you divide the coefficients. It goes to 1. Vertical asymptote. What makes the bottom 0 but not the top? -6. Vertical asymptote is a line. I need an equation to tell me to define a line. Horizontal asymptote, that's a line. That needs an equation. X-intercept and Y-intercept, those are points. Ordered pair. Ordered pair, I need 2 numbers to identify a point. I need an equation to identify a line. Okay. Holes. No holes, because I don't have any other discontinuities. Only the -6. If it's a vertical asymptote, it's not going to be a hole. Other points. Okay, let's graph. And then we'll say what the other points could be. Here are my axes. I've got a horizontal asymptote at y equals 1. I've got a y-intercept at 0, 5, 6. I've got an x-intercept at -5, 0. I've got a vertical asymptote at -6. I've got no holes. Did I have a hole in the previous example? Sorry for this break in the action, but I feel like maybe I cheated you. Oh my God, I didn't draw the hole. I'm sorry. Rewind. I wasn't done. I forgot this, and I hope you don't forget on the test, but I just forgot. X equals -7 was a hole. Ah. Oh my goodness. I'm sorry. Okay. That would have been points off for you, but not for me. Okay, so, well, I mean, you know, hopefully, like me, while you're taking the test, you'll remember, and you'll go back and fix your mistake. -5, -6, -7. Boom. There it is. Now it's perfect. Okay. Back to this function. Here we go. All right. So we got point here, point here. I can see what's going to happen here. It's going to do this, right? But let's do, tell you what, let's do a couple points here. This is -6, so let's do -7, -8. And I can kind of see what's happening. I almost don't need a point here, but whatever. We'll do -3. Okay. So these are easy enough to get. -3, I'd have 2 over 3. -7, I'd have -2 over -1, so that's 2. And -8, I'd have -3 over -2, so that's positive 1.5. And so here I am. Boom. Okay. And now I've got my curve. Well, that's not great there. That looks like, but, you know, we only live so long. Okay. And all right, so that's that one. Let's do another one real quick. One last look, okay? Number 3, what did we do? Oh yes, now for number 3, in class, I basically factored this for you. But suppose I gave it to you like this, right? Okay, so suppose I gave it to you like this and said, you have to factor it. So then you'd have to say, well, what do we got here? Top and bottom. And to factor it, I suppose I'd focus on the first term and the last term. I'd say, what multiplies to make 2x squared? I need a 2x and I need an x. What multiplies to make -2? Well, it's either 1 times -2 or -1 times +2. And then I got to think, what arrangement is going to get me a positive 3x? So I think, what would it be? -1 would give me -1x, and then +2 would give me +4x, and that would add to make this. So that's not too bad. And I wouldn't give you a really crazy thing. But remember, you can also graph this. Like if you graph just 2x squared plus 3x minus 2. So let's say you were keen to know the factors quickly, and you didn't want to just muddle it out, and you graphed this. And notice I'm only graphing the top. I'm only graphing the top of the function, not the entire function. So that top polynomial goes through -2 and positive 1/2. Okay, well, as you can see, x plus 2 is a factor, which goes hand in hand with -2 being an x-intercept. So when you see that x-intercept -2, you can say, well, I know x plus 2 is a factor. And then from there, you could get the other factor. Okay, so that would do it for you. And that technique I showed you for higher degree polynomials also. The bottom here, I think you could do the same thing, but I think, oh, no, I got that wrong. What should it be? That's not this. It's x minus 3 and x plus 2. There we go. That would do it. Okay, so finally, let's go through y-intercept. I'd have -2 over -6. That's a third. X-intercept. I think we can be done after this one. X-intercept, well, actually, we saw it on the graph. It's 1/2 0, and it wouldn't be -2 because, I mean, it is for just the top, but the whole function, -2 gives you 0 on top and bottom, and then that's indeterminate. So, or I should say undefined. I'll say undefined. So 2 times 1/2 minus 1 is 0. That's my y. That's my x-intercept. -2 is not an x-intercept, and in fact, that's going to be a hole when I get to that. Horizontal asymptote, same degree, degree of 2, degree of 2. I divide 2 over 1. Y equals 2. Vertical asymptote. 3 makes the bottom 0, but not the top. That's a vertical asymptote. -2 makes the bottom 0 and the top. That's a hole. And once again, 1/2 makes the top 0, but not the bottom. That's an x-intercept. All right? Get those things straight, and don't just memorize those things like they're, rules that you would never understand, but that you can memorize. There's a reason why those things shake out that way, and we spent, all last week really getting at what those reasons are. Okay, points. So we'll put this stuff on the graph, and then we'll decide what points we want to use. So I've got my axes, I've got my y-intercept, I've got my x-intercept, I've got my horizontal, I've got my vertical, yep. And points, okay, I want to know, let's say -4, I want to know how steeply this is happening. So 2, I want to know. And then like 5, let's say. Okay. And again, I can sort of cross these out and say, I'll just plug in -4. Here's my work down here. I'll just plug in -4 into this. So I have -9 over -7, so 9/7. 2, that'd be 2 times, okay, so 3, so -3. And then 5, that's 9 over 2. Okay. Which is like here. So 9 over 2, -3, 9/7. Okay, I can definitely see this happening now. Okay, so that's good enough. Okay, and this, maybe I would really want to plot another point if I wanted it to be great, but I'm good with that. Okay, that's all for this video. Okay, make sure that you understand not just what the rules are, but why they are as they are, and study them, and yeah, let's do it.